So you have a laboratory, right? And the guy had some chili or something for lunch. Right? He lets one go. What's interesting, though, is you can't smell that gas. It's flammable. You can light it, but you can't smell it. It's when you have a reaction that, like a lot of undigested bean skins. So these are your reactants, right? And then here's the process, right? There's something's going on. It's fermenting inside your gut and your intestines. And then here's the products. And the one that you smell is this one. These sulfur compounds, they really stink. Okay? But that's really the power of reactions. It really fits in with what we're trying to do in pretty much every science class. And that's to understand science so well so that you can make really good predictions to make everybody's life better. Right? For example, with a chemical reaction, there's chemotherapy. If you really understand what's going on inside that body, you can make dosage, right? You don't want to overdose, or you don't want to have too much reactant, otherwise the effects are going to be even worse. So by having chemical reactions, you can kind of predict, right, the outcome, and if you do this, give this dose, this will be the end result, right? There's other reactions where they don't know the process, like photosynthesis. We think we do, but we don't understand all of it. If we did, man, we could, right? We'd have free energy pretty much coming from the sun. So that's research going on right now. So that's kind of where we're at. We're just messing with chemical equations. And today we're going to work on just balancing them. Okay? Just balancing them. And how to write them. So here's a reaction. Now, these are molecules. They're not crystals. They're not ionic compounds. They're molecules. So we have, right, reactants over here and products over here. But is it balanced? Reactants, products. So the black is supposed to be carbon atoms. Right? The red is supposed to be oxygen atoms, and the blue is hydrogen atoms. So do you remember Dalton? He said that, hey, you can't create or destroy an atom. It's like slamming a whole new planet in a solar system or annihilating one. It can't happen. You have to have the same number of each type of atom on both sides of the reaction. So Alyssa, I don't know, does it look balanced? Like, I don't know, look at the carbons, for example. The carbons are black. Alyssa, is it balanced? The carbons are black. It looks balanced. I see one black on both sides. How about the Monica? How about the red, the oxygens? Do those oxygen atoms look balanced? Right? It looks balanced. I agree with her. And it's kind of new, but see, there's actually two oxygen atoms here. There's one and there's one, right? They're just chemically bound, right? That's the molecule idea. They're sharing electrons. Okay, she's right. How about the hydrogens, Jesus? The hydrogen atoms. They're the blue ones. It's really tough to see. How many do you see on this side? 4. On this side, there's one right there in the back. Yeah, so there's four blues on that. Okay, so it's balanced. We count the same number of atoms on both sides, except I don't know, drawing these things isn't going to work. We're just going to write chemical equations for them, right? So how would we write the chemical equation for this, right? Christina, how would you write the chemical equation for this guy? So we're going to have something plus something, right, on both sides here. How would you write the chemical equation, the chemical formula for this thing? Remember, the black is carbon, the blue is hydrogen, CH. Well, you could do a whole bunch of H's here. How many H's? 4. But they're not going to do that. They're going to write what? CH with a little subscript 4, right? So let's erase that. But you could do it that way. Okay. And how do you know the H4 isn't in front of the C or H2C, H2? Don't worry about that. We're CH. We'll be giving you these formulas. You don't need to worry about how they're written, just how to use them. How about the next part? Gilbert, what would you write to describe the other reactants? O4. That's one way. It works, but it doesn't model what. See, he's got 4 oxygens. It works. I hear 2O2 because there's really O2s and there's 2 of them. So better than O4 would be O2 and O2. But like Lauren said, one part of equations in math, man, is always they write things as with the least writing as possible, right? Which is kind of nice. You don't have to write so much. So instead of writing O2 plus O2, you'd write 2 O2s. Right? So that gives us 4 oxygens. So how do we get 4 oxygens? This is what you have to get used to. You have to multiply the coefficient, the big number, times the subscript. So you have 4 oxygens. You have to get used to it. Over here with the methane, you have 4 hydrogens times its coefficient, 1. Okay. The products, the first product. Kimberly, what would you write for the first product over there? CO2, carbon dioxide. And then, Shelby, we've got what? 2 waters. So again, you could write H2O plus H2O. That's getting to be too much, though. So it's like Shelby said, just write 2 H2Os. Okay. So now is this balanced? Lauren, are the carbons balanced? Carbons look balanced to me, too. Victoria, are the oxygens balanced? 2 times 2 is 4. And 2.
Oh, no, there's 4.
There's 4. You see the oxygens? See the trick to doing this? Make sure you can see 4 oxygens on both sides. Multiply the coefficient times the subscript. So I've got, right, 4 oxygens here, because 2 times 2 is 4. I've got 2 here, and I've got 2 here. Multiply the coefficient times the subscript. 1 times 2, 2 times 1. So there's 4 oxygens on both sides. Right? The hydrogens. How many do I have on the, Amy? How many hydrogens do I have on the product side? 4. She sees this. She knows how to do this. 2 times 2 is 4 hydrogens. Everybody, 4 hydrogens on that side. So it works. We're good to go. Okay. So that's the game we're pretty much going to be playing today, is balancing chemical equations. And it's going to be kind of random, so I only have a couple suggestions in doing it. We're just going to start putting coefficients. Remember, coefficients are these numbers. Right? If they say balance it, it's going to look like this. And you got to put the right coefficients in there. Can you change the subscripts to get something balanced? No, because do you realize the effect? Let's say you want, I don't know, 4 hydrogens on over here. So you erase that 2 and you make it a 4. You just change this up here, right? Now you've got one of those reds with 1, 2, 3, 4 hydrogens on it. That's not what the reaction says. You can never, ever change the subscripts, right? Because then you're changing the molecule. Can't do it. Can't do that. You can only change the coefficients. Get out of there. Okay. First helpful suggestion in balancing this stuff. Balance last any element that occurs by itself in the chemical equation. So if we were going to do this, you don't have to do it this way, but I strongly suggest it. You've got carbon, hydrogen, and oxygen to balance. Which one should you balance last, according to this little hint? The O's, because it's an element all by itself, right? It's an element all by itself. Balance it last, okay? I should add another one in here, 1 prime. Another thing that you want to balance last is something that appears all over the place. For example, let's take a look at one. Here's a good one. We're going to do this one, just to give you a guide, right? First, there's no element by itself, so there's no guide there. But look at the hydrogens and the oxygens. They are all over the place, aren't they? Hydrogen and oxygens are in multiple locations. Do them last. They are complicated. Okay? So when you get to number 4, do H and O last. That goes for pretty much any of these questions where you have the same element all over the place. Like look at 5. Which element would you want to do last in that one? Element. So you're not a complete compound, just one element. Ends. Do the ends last in number 5. Because look, they're all over the place. Now you don't have to, but your life is going to be more complicated if you don't. So that's my other little hint. Okay. And then combustion reactions always produce something and something. So as reactants, as products, if something's burning, you always get this and this. Does somebody know what it is? It's actually this is a combustion reaction. You get carbon dioxide and water. Right? For any combustion reaction, you get carbon dioxide and water. See how you're reacting oxygen? It's actually burning. You always produce CO2, carbon dioxide, and water. Okay. Yep. Oh, for 1 prime, I would say do last elements. That's a good one. I'm glad you asked this, Teresa. Do last elements that show up a lot, right? Or that show up all over the place. That show up in all these elements on both sides, all over the place, right? There are all these reactants and all these products. Do them last, okay? So let's try one of these. Try a couple. I'll just try one of these, and then we'll go to the boards and see if we can knock these out. Frankie, I want to do number 1. I want to balance it. And which element should I do last? Don't touch it to the end. Well, I could start there, but do last. In other words, I want to balance him last. I have to balance Na, S, O, and I. But which element should I? Don't leave it for last. All right. This hint, the I. Now, you don't have to do it this way, but life is so much easier if you do. Because I've done this before. So do I last. Okay, good. So, Jarixa, what should we balance first then? Pick an element. Pick an element, S, right? So pick an element. She says do the S's. Okay, let's do the S's. I have how many sulfurs on the, Christine, on the reactant side? How many sulfurs do I have? 2. Do you hear it? Everyone agree? She just says 2. Multiply the coefficient times the subscript, just 2. 2 sulfurs. On the product side, how many do I have, Alyssa? Sulfurs. 4. All right, so how am I going to fix this, Monica? What could you do? Yeah, add a 2 over there on the product side. Just put a 2 there. And you change color here a little bit. Okay. So sulfurs are done. Jesus, what element do you want to balance now? No, not all we did is sulfur. So Na sounds good. Na, all right. So how many sodiums? Where? This is the reactant side. Yeah. Well, I have 4 sodiums. On the product side, everybody, I've got how many sodiums?
3.
I've got 3. Good eye. So how are you going to fix this? Add a 2 in front of the NaI. All right, one more time. We've got 4 sodiums on the product side. Sorry, 4 sodiums on the reactant side. 2 sodiums and 3 sodiums on the product side. So you guys are saying the solution is right here. Right? I got 4 sodiums. Sodiums are done. Okay, Gilbert, now what? What element? Sulfurs are done. Sodiums are done. Now what element? What element should we balance next? Oxygen. Sounds great to me. How many oxygens on the reactant side, Kimberly? 6. 2 times 3 is 6. How many on the product side, Shelby? How many oxygens on the product side? 6. Hey, nice. All right. So, Lauren, there's only one element left, and that is the I's. Are they done? Yeah. Right? Okay. So, have at it. Right? And help your neighbors and ask if you're not sure. I'll be glad to help you out. So, let's just go to the boards and we'll get these out. Life will go a lot faster. Okay? It really will be more enjoyable, I promise. Okay. Got some chalk. You don't want to write with little pieces. I've got big pieces. Okay. So tiny though. They're so tiny. Okay. Spread out a little bit so you can give yourself each some room here. We're doing number 2. We're doing number 2. Doing number 2. Hopefully you're doing oxygen last on number 2 here. C6H6. They're together. And you start somewhere. You can always erase. Now, why'd you put a 3 here?
Because I want 6.
If you want 6 C's, you have to put a...
But wouldn't that give me 12 of this?
You worry about that later. Put a 6 there.
Oh.
Yeah.
So
6.
go up.
Huh? We'll balance him last. Leave the oxygens for last, right? So just put a 6 in front of the CO2. That's a good one. Good place to start. You don't need to rewrite it. Just put a 6 in front of there. Right? Oh, it's going to get really ugly and messy. Then try balancing something else now. Good. Now you have to balance the O's. Everything is balanced but the O's.
Oh, okay. Because I have 12.
It's an odd number, isn't it? Okay.
Yeah.
Let me show you the trick to this. Okay, hopefully, I was waiting for you to find that. Okay, so I think everyone pretty much started where? You put maybe a 6 here?
Yeah.
Because then I have 6 carbons on both sides. And then you probably did the hydrogen, hopefully did the hydrogens next, right?
Yeah.
So what did you do to fix the hydrogens? A 3 on the H2O. Okay, so everything's looking good except the oxygens. How many oxygens do I have on this side? 15 of those stinking things. Okay, it's an odd number. The trick to doing it is cheating. 15 halves times 2 is 15, right? It's balanced. It works, except it's not conventional. So what do? How do you fix this? Multiply the whole thing through by what? Because it's balanced right now. It's done. You could quit, except you can get a point off. Multiply everything through by 2. Multiply everything through by 2. So you'd have 2, 15, 12, and 6. That would be your final answer. 2, 15, 12, and 6. Okay? So it's kind of cheating, but not really. I mean, we fixed it in the end. Okay. Try 3. Now try 3. Notice H appears in a lot of places, so I would do H last in number 3, because before I start these, I kind of look at them and see which one looks really hard. And there's nothing by itself in number 3, so there's no clue there. But look at the H's. They're appearing in 3 places, so I would leave them for last. Don't do the H's first. I think that'll screw you up. Do something else first. Leave the H's for last, because there's a lot of them in number 3. If you can get away from doing it this way, your life is going to be a lot easier. I'm serious. It really will be. No, 15. See, when you multiply this through by 2, the 2 cancels with the 15 over 2 times 2 is just 15. That's why you end up with just 15. Yeah, try number 3 now. If you got 3 done, then go on to 4. But in 3, those hydrogens are all over the place, so I would leave the hydrogens for last in number 3. Start somewhere else. Well, that looks right. I think you got it. So if you can get away from doing it this way, your life it will be easier.
Really?
It will be. I promise. Okay. So let's do it. Let's do it the old man way. Okay. You probably were really close, but it's so much easier if you don't worry about it. So if we just put our lines in here. So first you look at it, and you say, H's are a lot of places. Leave them last. So you just pick one. P, I don't care. P, oh, P's done. Okay, fine. Cl. I have 5 here, so, okay, 5 there. Okay, now let's, remember H's are last. Let's do O's. 4 here, but there's 4 here. So you have to put 4 there. Okay. Now H's. How many H's on this side? 8 and Yeah, you're done. Right. So try to get away from doing this. Just messing with the subscripts. Your life will be a lot easier. Okay? So do you have, here's an eraser. Okay, give yourself some space here. Now, it's PCl5, H2O, isn't that H3PO, H3PO4 plus HCl. Blank, 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 right? So see how the H's are in multiple places, so leave them last.
So it's a P first.
P's done, right?
Yeah.
Okay, chlorines.
There's
5 chlorines, so
There's 5. There's 1 here.
so
Please just put the 5.
perfect. Okay, H's are last. Let's do O's next.
Alright. So that there's 1, there's 4, 6, or
Really good. Okay, now H's.
8. And then here's 5, there's 8.
Yep, you're done.
Oh, I was doing it.
You're done. Okay, did everyone have 3? Whoops, sorry. Everybody have 3 done? No? Okay, let's try 3. So you see H's. If you got 3 done, go on to 4. So let's see. See how the H's are in multiple places? So leave them last. They're complicated. So I don't know, you start anywhere. P's. P's are done or what?
Single, so yeah.
Yeah, they're done. Okay. And then,
Scratch them out.
no, they're done.
Oh, so
The
they're
ones,
done. All right.
right? And then, okay, fine. The chlorines.
You got 5 chlorines, 1 chlorine.
Yeah, so put a 5. Yeah. Well, put it in front.
Would it be a 4 because it's already 1?
Well, no, 4, you have to multiply. It's,
5 times 1.
that's why I like putting these blanks here. Because this is what you have to multiply. You have to multiply this times that to get the number of them. So if you put a 4, or no, we said 5, right?
Yeah.
5 times 1 is 5.
And 1 times 5 is 2.
Yep. So that's done.
Okay.
And now I think H's.
I have 2 hydrogens, and I have 1.
What times 5 though?
So
5 plus 3 times 1. 8. So how would you fix it?
4.
Yep. All right. Now the oxygens. They're last. Or
You got 1.
well, 4 times 1.
So I'll put a 4 here.
No, 4 times 1 is
it's already
4.
there, 4 times 1. It's already balanced.
Yep. It's gone. You're done.
That's pretty easy.
So so just remember, it's coefficient times subscript. That's the number. So that's 4 is as ugly as it's going to get. And leave space for your coefficient, right?
Can we first distribute so we can have it all, or is that last?
Well, I would pick in number 4. H's and O's are a lot of places. Do them last. Doesn't matter. Do N or S or NA. Who cares? Do those first before you even touch H's and O's.
Excuse me, it will be the same thing we do it like this. It's gonna go to both of them, right?
If you do what?
Like, if I wanted to say, oh, he said leave NH last.
No, leave H's and O's last.
Okay,
Look,
so what
H-O,
happens if I
H-O,
would-
H-O, H-O.
If I would want to do N,
You want to do N? Fine. Okay. Now give yourself a, you're not going to be placed to write your answers here. This is the coefficient for that one. Where's your coefficient for this one? Wow, here, right? Okay. So if you want to do N's, fine. How many N's do you have on this side? That's not an N.
it's only 2.
There's only 2.
Yeah.
Good. You have 2 nitrogens here. How many nitrogens on that side? What the heck is this? Shouldn't that supposed to be an NH3?
Yeah.
You're right. You have HH3.
It's N.
All right. So how many N's on this side?
It's already the same.
We have 2.
Oh, so you put 2.
There you go. Okay. And now what do you? Just don't do. Yeah, do S. Fine.
Alright. There's 1 and 1.
Yeah. So good. Leave them alone.
So then type of let's do the NA.
Na.
There's one over here. There's two over here.
Yeah.
There's
Perfect.
two.
Yeah. Now you mess with O's and H's.
All right.
Uh-huh.
So this 2 does go for
Yes. It means you have 2 N's. You have 8 H's. Yes.
I couldn't resist that. I didn't use that for this one, but this one's like.
Yeah, you don't use this.
So how
It's
am I
too
supposed-
ugly.
I already tried your way and it didn't
Yeah, you
work.
can. Look, first you need blanks. You need. Where are you going to write your coefficients? Right? Write some blanks here somewhere. Otherwise, there's no place to write your answers. That's not a coefficient. Where are your coefficients at?
Oh.
What about this one? He needs a coefficient. Okay. He needs a coefficient. He needs a coefficient. So you should really space it out. It'd be a lot easier to see. Okay. Now, looking at this. There's no element by itself, so that's no guide. But what elements appear a lot?
H and O.
So don't leave them last.
Okay.
They're way too
I did
ugly.
that.
So start with one.
N.
Start with something else. N's. Okay, how many N's do you
2.
have over here? 2. So what do you do on this side?
And then add 2.
Go ahead. Okay, now pick something else.
An S.
S.
1 S. 1 S.
Good. Pick something else.
N A.
Na. Good.
I have 2 over here and 1 over here.
Yep. Okay.
Okay.
Now what?
Now the H and O.
Yeah, let's pick one. Fine.
8.
8.
10.
8 and 10. So you have 10 over here, right? 10. Oh, we're going to forget that number. 10. What do you have on this side?
6. 7.
8. Okay, how are you going to fix this?
Adding 2.
Very, very good. Okay, H's are done. Now try O's.
4. 5, 6.
6 O's.
2. 6.
Mm-hmm.
Oh.
Show Christine how you did it. Show Christine how you did it. Oh, let's see if the O's. We've got 4 and 2 is 6 O's. Yeah, this looks right. Yeah, 8, 10 hydrogens, 6. Yeah, looks right. You got it.
Sodium I had 2 and
Did you get this, Amy? No?
Because
You don't think so?
I was trying to figure it out
That's
and I
right.
kept getting confused in my head.
And then that's 5.
So you don't think it's right?
first
I'm not sure if it's right.
Oh, we can check. So we have 4 oxygens and 2 oxygens, 6 oxygens. Here we have 2 and 4, 6 oxygens. How about the hydrogens? 2 times 2 is 4, and 6 is 10. 8 and 2 is 10. It's
That
right.
changes that to 4.
That's
so
right.
That's
I
4
kept counting, I
plus-
was getting the wrong number in my head.
No, that's right. I wouldn't do it this way, Frankie. No, it is the real hard way. So let's just draw our blanks in front of these so you can so you see what the stoichiometric coefficients are. Oh, no,
Oh, no, that's
theirs.
just
Yeah, yeah. And on this side, you need them too. And you need one for the sodium sulfate.
Oh, for that one too?
Yeah, and you need a coefficient in front of everything.
Oh, okay.
And this says Na2SO4. Okay. Now you first, before you even start, you look at this and you say, hey, which elements are showing up a lot? Oxygen is showing up a lot. What else is showing up a lot? So leave them last. So pick something else, and that's where you start. So Na. So fine, start with Nas. 2 there. Yeah. So. Yep. Okay. Now I go on to something else. Yeah. Now you have 2 N's though. 2 N's.
two ends over here, and then you have one over here.
Yeah.
So if I have one over here, I should throw two. Over
There you go. Okay. Now something else. S is the only one left.
Yeah, is that four? Four is
No,
only for the
four's
oxygen?
on the four's only on the oxygen.
So the S is by itself.
Yeah.
And there's same thing over here.
Yeah. So S's are done. Now you gotta do an O or an H.
O4 is over here.
Yeah.
O5. And you have to
Yeah, you have to multiply the coefficient times 6.
six O's over here. 5 over here.
Yeah. Yeah, you said you had 6 O's over here, right? 6 O's. This side, you said only has 5. So you have to add oxygen to this side. So you're going to be changing either this one or that one.
The add oxygen.
Yeah. So which one are you going to change, this one or that one, to make this work? To get 6 O's. Think of it this way. You have 4 O's here. Change this to a what, and I'll have 6. 2.
Oh, yeah.
All right. And now the H's, I guess.
So this side is 5 or 6.
2 times 3 is 6, plus 2 times 2.
10.
10.
10. Over here, the 1.
Well, 1 times 2,
2.
plus
Oh, yeah, the other 2 over here. So that's 4.
2,
2 times 4?
2 times 4.
So 6.
8. 2
8.
times 4 is 8.
10.
10.
Oh, so
Another.
it's already done?
Yep. You got it.
That's it. Everything?
Mm-hmm.
Let me see.
Yeah, or start, erase them all and start again. See if you can get it again on your own. If you got all these done, go ahead and work on the naming. Okay.
3 ends, and then we have 2
2.
ends.
That looks good.
And then
It's right. It's right.
okay, so 2, 3.
Need help with any of these, or you got them?
I got this one.
Really? Excellent.
Yeah.
But now I got this.
Amy, how's it going?
Oh, okay.
Is that your final answer?
Here we go.
Let's check the O. Like the O's are everywhere, so the O's are right. It has to be good, I think. 6 and 1 is 7. Looks good to me. Okay, Monica, you got it?
Yeah, I just got this.
Excellent. Kimberly, figuring these out?
Yeah, but
So what are you balancing first there? You put it.
I already had balanced this and I had a 2 right here.
All right. Oh, but remember this is an N too, isn't it? Isn't that an NO?
Oh. Oh yeah.
So you have 2 and 1, right?
Yeah.
So yeah, leave him alone. There you go.
Still 6 and O, aren't I?
Well,
So it's like 5, 3.
well now that there's not very many H's. Do the H's next. You know the ends. You know what? Notice how the ends, Kimberly. N here, N here, N here. It's just not working. And plus, it's too. So start with start somewhere else. Don't start with N's. Start with something else. Yeah, start with the H's. Yeah. Okay, now I'll go on to, I don't know, the O's and the N's were horrible. Or the N's, it doesn't really matter. Yeah, O's are ugly. Try the N's.
Yeah. 1 and 2, 2, 3.
Okay.
So can we get this?
Yeah, let's try that.
6, 7. Okay. Yeah.
That works?
Yeah.
See, so that's the advantage of just messing with the coefficients. If it's ugly, you just erase them and start over with something else.
Instead of doing the whole
Yeah. We have a few more minutes.
Start off with the H. So I already have 2 here and I have 1.
Yeah.
So I did put.
Yeah, good.
And then
Okay.
my next one I'm gonna do N.
Okay.
I got 1 here, right?
Yeah, but don't no,
2 times 1.
2.
2
Don't forget that one. You have 3. You have 3
I got 1
ends.
here.
So put a
3.
3 there.
I got
Now
3
check
ends.
out the O's.
Oh yeah. And then O, I got 6 O's plus 7.
Yeah.
6, 7.
Yeah, you got it.
That's ammonium. Ammonium sulfate. And you want it to. Well, that's basic molecular. So I go from there. Oh no. Do you see that? Because ammonium is +1 and the sulfate